Alright, let's talk about number 5. This is number 5 of the second group of questions in the packet. Alright, this is also the one that had the small typo. I sent out an email for one of the classes because that was 480 torr and it didn't make any sense of the torr and torr, so I changed that to milliliters. Okay, so you might have to change that in your paper. Anyways, let's read it. At conditions of 785 torr of pressure and a temperature of 15 degrees Celsius, a gas occupies a volume of 45.5 milliliters. What will the temperature of the same gas be at 745 torr and 480 milliliters? Alright. Well, first of all, doing any of these problems, you really have to use your reading and see that it's usually quite obvious what we're looking for. We're looking for T. Okay, we're looking for T2. How do I know that? Well, it says, what will the temperature be? What volume? What pressure? Okay, the what word is actually quite powerful, and if you look on your paper, basically all the questions are quite obvious with the what followed by the actual variable you're looking for. So we're looking for T2. Okay, so that's my first inclination. Second inclination is I've been able to identify the groupings. Okay, first of all, what equation are we using? Well, if you look here, we have pressure, volume, and temperature all being dynamic or changing. So we're going to use the combined gas law problem or equation. Okay, combined gas law was PV over T equals PV over T. And just to sort things in my mind, I always like to make a small variable sheet. Okay, so I'm going to say PV and T, and we'll do PV and T, put 2's and 1's. And I'm going to fill it out based on, we already know we're looking for that one, T2. I'm going to fill it out based on all my information. Lay it all on the line. Okay, my P1 is 785.0 torr. My V1 is 45.5 mLs. My T1 is 15 degrees Celsius. Okay, but we must use the Kelvin scale. So 15 plus 273 is what? I have 288 Kelvin. The P2s are 745 torr and also 480 milliliters, 480.0 ml. Alright, from now it's just basically a plug and chug problem. I have 5 of the 6 variables. It's up to me to be able to use my equation here in order to solve for T2. Typically, solving for temperature is the more difficult problems, and that's why I picked number 5. Well, if this were me, and we know this from when we're doing the thermo, the way I like to do it is solve for the variable first, and then put the numbers in. Okay, I will do it both ways for the purposes of discussion here. If I was going to solve for T2, the first thing I would do is cross multiply. You cross multiply, you're going to get this equation. Okay, everything's perfectly legitimate, that's a 1. Temperature times pressure volume, but notice it goes 211 and then, and I'm sorry, that's got to be a 1 on this side. I spotted that. And then a 122. Okay, so the temperature doesn't match up with the PV because again I just cross multiplied. Kept it the equal sign and multiplied it on the diagonal to flatten it out. To solve for T2, I'm going to divide both sides by P1 V1 and I get this. T1 P2 V2 over P1 V1. plugging in our values, and hopefully, you know, a lot of us start to see that maybe this is the easier version of doing these problems. Feels like I'm going to run out of room. P1 is, P2 is 745.0 torr. Sorry for the sloppiness. Again, I'm running out of room. I realize that. V2 is supposed to be 480 ml. Realize, hopefully you're doing this with me. I realize it's hard to see. Again, I realize I'm running out of room. 785.0 torr. And lastly, V1 is 45.5 ml. Torrs cancel with torrs, mLs cancel with mLs. You're left with the unit of K, which is a temperature unit, and that's what you're looking for. Multiply these three top numerators divided by the 785, and then divide it again by 45.5, and that should get our answer. Okay, I don't have my calculator, but I emailed the answers out earlier today. Now, that's how you do it my way, which is solve for the variable. I realize in a lot of our math classes we use the insert and then manipulate the equation afterwards. To me, I think it's a lot more writing, but I realize that that's how we're taught in a lot of our classes, so I'm going to do it that way as well. Don't know if I'm going to have enough room. Looks like I'm probably not. May have to erase. Alright, so if I do it this way, I'm just going to have to erase this side, so hopefully you hit pause and wrote that down. If not, you're going to have to rewind. Let's do it this way. I'm going to, you can just get rid of this. Plug all the values in and then manipulate it afterwards. So it's going to be 785.0 torr times 45.5 mLs, P1 V1 over T1 equals 745.0 torr, 480 ml over T2, which is T2, unknown. Now I have everything in. I'm going to do the same step though, and due to space, this is going to have to be my last step. What I'm going to do is cross multiply. I know a lot of us get into a little bit of a rush, and we don't want to do all the steps. And some of us can come up with the right answer that way, and some of us get the answer wrong. So, to me, it's, if you have enough time, it's much more efficient for getting the answer correct to slow down and do it efficiently. Okay, I'm going to do the whole cross multiplying with my variables and my units throughout. Of course, I'm running out of room here. 480 mLs and my 288 K. I realize 288 Kelvin is squished on the side there. Okay, now that I flattened it out and I realize that it gets a little sloppy here, I'm going to divide. I'm looking for my T2. Right, let's underline it. I'm looking for my T2. Before we actually cross multiplied, it was in the denominator, and that makes it much harder to actually solve for. Alright, it was in our denominator, and that doesn't really help us out much. We have to really get it in the numerator, and the cross multiplying is why we pulled that off. Okay, flattened out the problem. It's not a fraction any longer. I'm going to create a fraction when I go back to red, divide both sides by 785 and the 45.5 mLs. Cancel, 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 cancel. And you have to do that to the other side. I do the same thing. 785 Let me actually try to squeeze this one in. Okay, 785 torr and 45.5 mLs. And lo and behold, what do we have? Okay, and I realize it's hard to write, hard to see. Again, I apologize for the space. These are much larger questions than we're used to dealing with. Okay, and I'm not on my preferred tablet. Okay, lo and behold, what do we have? Remember, all this stuff gets canceled out. We're left with what? Well, if I erase the top here, just rewrite it once, you'll see that we're left with exactly what we had on the right originally. It took more effort, took more pencil writing, but we finally got to the same place we were before. Because what do we have? We have T2 equaling all of this. 745.0 torr, 480 mLs, 288 K, all over 785.0 torr, and lastly 45, and I wrote this much nicer, 0.5 mLs. Okay, mLs cancel with mLs, torrs cancel with torrs. We're left with K. We're supposed to have K, and we're at the exact same place that we were when I did this on the right side by just moving the variables first. It's much easier to do it that way. Okay, so again, you'd say 745 times 480 times 288 divided by 785 divided by 45.5 and get the correct answer. Again, I implore you to check out those answers that I emailed out earlier today. This is about as hard as it gets too. Solving for temperature in the combined gas law is one of the more difficult aspects of the gas laws.